Integer exponents. Our objective is to evaluate and simplify expressions containing zero and integer exponents. Who uses this? Manufacturers can use negative exponents to express very small measurements. Remember, this one's your base, and that's your exponent. So say we're given the power 5 to the 5th. That value is 3,125. Well, if we go down one more power, so we have 5 to the 4th, we're essentially going to divide this value by 5. And 5 to the 4th is 625. If you continue this pattern, so as you decrease your exponent by 1, you're going to divide each time your base by 1. What happens when we get to 0 and -1 and -2 and so on and so forth? Well, when the exponent decreases by 1, the value of the power is divided by 5. So if we're at 5, we're going to divide by 5, and we're going to have 1. So 5 to the 0 is 1. Okay, well, if we're at 1 and we divide by 5, that's 1 divided by 5, or 1/5. 5 to the 2nd would be like taking your 1/5 and dividing it by 5, which is the equivalent of 1 over 25, or 1/25. You can also think of it as 1 over 5 to the 2nd. This is going to help you understand integer exponents. A zero exponent, any non-zero number raised to the 0 power, is 1. Because it's like taking your base and dividing it by your base, so it's always going to be 1. 3 to the 0 is 1. 123 to the 0 is 1. -16 to the 0 is 1. You can even do a fraction or a rational. So we get 3 over 7 to the 0 is 1. Okay? A negative exponent is a non-zero number raised to a negative exponent is equal to 1 divided by that number raised to the opposite or positive exponent. So say we have 3 to the -2. That's equivalent to 1 over 3 squared, and you can reduce it from there, so 1 over 9. Basically, if you were to think of 3 to the -2, if you were to write that as a fraction, you would put it over 1 to make it a whole number, or it is a whole number, so you'd put it over 1. So now, because you're essentially going to make it a non-negative exponent, you're going to stick it down at the bottom, so you have 1 over 3 squared. You can do the same thing with 2 to the -4. So you have 2 to the -4. To make it so that this is a non-negative exponent, we're going to put it downstairs. So instead of it being on the top, we're going to put it on the bottom, and it becomes positive. So let's look at a manufacturing application. The diameter for the Model A Ford piston could vary by, at most, 10 to the -3 inch. Simplify this expression. So we have 10 to the -3. Well, it's a negative exponent, so that means we can go 1 over 10 to the 3rd. If you need to write it out, it's like saying 1 over 10 times 10 times 10, yes? Okay, well, that's really 1 over 1,000. So 1/1000th of an inch is how much it could vary at most by. So let's practice dealing with zero and negative exponents. So we want to simplify each one of these. Take a moment and try A, B, C, and D based on the rule that we talked about. Alright, so now when we try A, so we have 2 to the -3rd, so that's like saying 1 over 2 to the +3, because as soon as it comes down to the bottom of a fraction, or into the denominator, it becomes a positive exponent. And then we can simplify this one more step. So 2 to the 3rd is really 8. Anything to the 0 power is 1. We don't even have to do much for calculation there. And now we've got C. We've got -3 to the -4th power. So this is like saying 1 over negative 3 to the positive 4, because once you put it downstairs, it becomes a positive. And you can think of this as 1 over 81, because negative 3 to the 4th is 81. For this one, it's a little bit different. Notice how in C, the parentheses were around the negative 3. We don't have parentheses around this one. So the negative kind of chills out in front, and you're only going to play with this part right here. So we have negative, and then it's 1 over 3 to the positive 4 now. So your negative still stays out in front, and we talked about it here. So 3 to the 4th, well, 3 to the 4th is 81. So we have 1 over 81. Sorry about that, I kind of drew my fraction over my negative sign there. There we go. Let's take it a step further. Now let's try evaluating expressions with 0 and negative exponents. So we're going to substitute 2 in for x. So we have 2 to the negative 1, which is really 1 over 2 to the first power. And 2 to the first power is 2. So we have 1/2. Take a moment and pause the video and try B. When you return to the video, the answer will be revealed below. So we substitute 8 in for A and negative 2 in for B. Well, 8 to the 0 is 1, and then we have the quantity negative 2 raised to the negative 3rd power. So that's like saying 1 over the quantity negative 2 to the 3rd power. And we can simplify that again. So we've got 1 times 1 over negative 8. So that's what this is equivalent to. And then 1 times 1 over negative 8 is in fact negative 1/8. Let's step it up a notch. Let's try simplifying these. So when you do this, you have to pay attention to what exactly has the negative exponent. Notice how the negative exponent does not go with the 3. It is only with the y. So only the y moves. So when you do this, you can think of it as 3 times y squared to the negative 2 over 1 if this helps. And then just this y to the negative 2 moves down. So you have 3 over y squared. You can also write this, if you wish, as 3 times 1 over y squared. This is a little bit easier to look at, so that is the preferred method or preferred way of seeing an answer. Now let's look at B. What happens if it's already downstairs? It's already in the bottom of the fraction here. Well, you got to move it. By moving it to the opposite side, it's going to make it positive. So this k to the negative 4th is going to move to the top. Now, this says negative 4. The exponent has to be negative for it to be moved to the bottom of the fraction or to the top of the fraction. So if there's no negative exponent, it doesn't go anywhere. So this negative 4 is going to stay on top. And then this k to the negative 4, we're going to move it up to the top so that way it becomes positive. So we've got negative 4 k to the 4th. If you need to, you can write it over 1 if that helps. Now let's try this last one. Well, a to the 0, anything to the 0 power is 1. So let's start with that. We have x to the negative 3rd, and then we've got 1 times y to the 5th. Well, 1 times y to the 5th is just simply y to the 5th. So we almost don't even need this in there. Okay? Yeah, I'll change colors with that one. We'll use green. That way you can make sure that you've got it. Alright, so now we need to move this one right here because it has a negative exponent. So if it's on top, we're going to move it to the bottom to make it have a positive exponent. So you need a placeholder on top. So right now, on the bottom of the fraction, you have the y to the fifth, which isn't going to go anywhere because it's already positive. And you're also going to have this x to the third now, because by moving it, you change it to a positive. But you need a placeholder. Your placeholder is 1. So you have 1 over y to the fifth times x to the third. And that concludes our video lesson on integer exponents.